Hi guys, welcome to Sapima tutorial. We want to solve this interesting circle theorem problem on the board, alright? We are asked to find the angle at this position. Let me name it theta from the equation CDE. CDE. So this is what we are looking for. Alright. Observe the diagram. This line and this line are parallel. Okay? So I'm making use of this line to get the angle I am looking for. But meanwhile, also observe these two angles. These two angles are opposite interior angles of a triangle, which is opposite to this angle. Let me name it alpha. So if I get the angle at this position, I will comfortably get the angle at this position. If I extend this parallel line now, you discover that I will have a diagram that will look like this. Parallel lines, this and this are parallel. And this line now crossing like this as a transversal. Alright? So this place and this place are supplementary. So once I've gotten the angle here, I'll get the angle here. Remember what a supplementary angle is. Two angles that will add up to give you 180 degrees. That is supplementary angles. So my business with this diagram now is to use this angle, these two angles, get here. Once I've gotten here, I'll take the supplementary angle that will give me this one now. So let's apply logics to solve it. So I'll say let this angle CDE be equal to theta, and this angle, let's name here T. This angle BTD, BT and D be equal to alpha. I don't want to use these ones to solve so that I will reduce stress. So I'll use alpha and theta to be solving. But before you do that, you must define your parameters before you change the parameters you want to use. So let's go. Recall that this angle here, angle BAT, that is this angle, the angle here, plus this one, AFT, or rather E, let's use E. A, F, and E. If I add these two angles, I will have the angle outside. Look at this line. It is outside of this triangle and it is opposite to that angle. So I will call it ATD, the angle here. ATD, the angle at this position. So let's fix in the values. This is 65 degrees plus here 85 degrees. If I add the both of them, I will obtain the angle here, which is 150. So angle ATD is equal to 150. I've got the angle at this position. Then from there, I'll move on to get the angle I am looking for. To get the angle I'm looking for, I'll say the angle here, BTD, this angle, BTD, plus the angle here, I've named it theta, will sum up to give me 180 degrees. Supplementary angles in a parallel line. When you have parallel line, these angles are facing themselves. Both of them will add to give you 180 degrees. So this is it. Parallel, parallel. This is transversal. If you extend this one also, you discover it's a parallel line. So we quickly go. We have gotten BTD, which is same as ATD, this angle here. We named it alpha, so can I use alpha and theta equal to 180 degrees? So having gotten this, recall that my alpha, which is ATD, is 150 degrees, and my theta, I don't know it. So I'll call it theta, is equal to 180 degrees. Then from there, we move on to make theta the subject of formula. That is 180 will subtract 150 degrees. If I subtract, I'll have my theta to be equal to 30 degrees. So the angle at this position is 30 degrees. All right, and that is the solution. Thank you so much for coming on board. Please do not forget to subscribe to my YouTube channel, like my videos.